I have 5. I'm going to write a little bit smaller so I can have get everything in. You factor the denominator, correct? Into x plus 3x plus 1 minus 2x plus 2 over x plus 3 minus 3 minus x over x plus 1 set equal to 0, correct? Then you stated two restrictions, not negative 3 and not negative 1. And then you did this, which is x plus 3 times x plus 1. Agreed so far? Okay, this one needs a 1, this one needs an x plus 1, and this one needs an x plus 3. Agreed? The numerator is okay. The first one is 5 minus 3x. But here I have to be very careful. Negative 2x times x is 2x squared, but with minus in front, negative 2x squared. 2x times 1 with minus in front, negative 2x. 2 times x with minus in front. And 2 times 1 with minus in front. So far, so good? Minus 3 times x. Minus 3 times 3. Positive x times 3. And positive x times 3. Positive x times x. And positive x times 3. Now in descending order. First, these two. So negative x squared. Then I have negative 3x with positive 3x. These two go away. But I have negative 7x. So these are done as well. Now the free term, 1, 2, 3. So negative 11 plus 5, negative 6. Did we all get this? Did we all get this? Yes? Okay. If you made a mistake, it's okay. We'll look at the next one. Okay, what now? After all this effort, I changed it into a proportion, which I like. So negative x squared minus 7x minus 6 equals 0. Quadratic, negative leading coefficient. I will not let that stand in my way, ever. How will I factor? X squared plus 7x plus 6. So it appears that the equation has two possible solutions. The first one is, the other one is, and you can say not so fast. That's why I wrote those. So the conclusion is, negative 1 is not, but negative 6 is. A lot of work, right? Any questions on this problem? It's okay if you made a mistake. We learn from those, but from mistakes. But is the process clear? Now look how many different topics one can be tested on with just one problem, right? Number 1, how to factor. Number 2, how to find the least common denominator. Number 3, how to state restrictions. Number 4, how to deal with a proportion. Number 5, how to deal with the quadratic equation. Number 6 is factor again and find solutions. Number 7, if you want, check against the restrictions and then identify which is the solution. A lot of steps and a lot of different topics are tested with just one problem. Okay, so let's, now which one would you like? D first and then B? 1 over x minus 3 minus x minus 4 over x squared minus 9 equals 1. You can come up with your own method. So for example, if you have 1, you may say, I don't want to move 1 to the other side. I want to leave it on that side, and then I'll cross multiply when I change the left-hand side in one fraction. It's up to you. Create your own if that's what you want to do. I personally prefer moving everything because when I have 0 on the other side, it would be easier. But you may say, no, I found my own method and I'll accept it. Promise. Let me know if you need help. Good. Yes. Do not write the equal symbol here because there's only one equal symbol. Just making sure. Okay, yeah, that's perfect. Yes, I accept that. But not the second equal symbol. Right? Good. Yes. No, it's 1 over 1. So it means everything. 1 over 1 means x squared minus 9. Yes, it's good to write it as 1 over 1, so you yes, exactly. Yes. And then write the fraction line and the equals, exactly, yes. So this was a little bit easier, because it didn't have so much going on in the numerator. So 1 divided by x minus 3. Do we need more time? Sorry. Minus x minus 4 over x plus 3, x minus 3. Do you want to move 1? I prefer having 0, because it's easier when I cross multiply. So minus 1 over 1 equals 0. 2 restrictions. Which restrictions would you write? Excellent. Now remember, if you forget this, you are changing into an expression, you will not solve an equation. So the LCD is?
X minus 3x plus 3.
Very good. In any order, that's fine. And now here we need, yes. And here we need 1 because it's the same. And here we need the whole thing, x squared minus 9. Yes, you can write it as x plus 3 times x minus 3, but then you have to multiply it. So can anyone dictate the top? And of course I have 0 over 1 because now I changed it into a proportion. So the top will be, yes. Yes. Do we agree with all steps? Okay. So now these two go away. Then I have negative x squared, and this is 7 added to 9, which is positive 16, over x plus 3, x minus 3, equals 0 over 1, because it's a proportion now, which means negative x squared plus 16 equals 0. Denominator didn't go anywhere. When I multiply these two, I got 0. That was the purpose, to simplify it. Then I multiply by both sides by negative 1. So I have x squared minus 16 equals 0. And then I have x plus 4, x minus 4. And I get two solutions, plus or minus 4. Here's my first thought. Are those among the restrictions? Did we all get the same thing? Okay, one more. This one, it has a little twist in the denominator, and I have to be very careful. I still recommend moving both fractions to the other side. So let's see how we do on this one. So 12 minus 6x divided by x squared minus 4 equals 3x over x plus 2 minus 3 minus 2x over x, over 2 minus x.
Oh, you have to repeat them.
No, this one first. You have to take it aside, put it in descending order, and then factor on it. Everything, no, everything you did is fine. But that will be the next step. Everything you did is fine. No, don't change anything. I'm just saying now put 2 minus x on the side. 2 minus x. No, don't change anything. I'm just saying right here 2 minus x. Everything you wrote is good. 2 minus x equals negative x plus 2 equals minus outside parentheses x minus 2. Now you have to put it back in here. So you have to rewrite with that. Yep. Yep. Everything you don't erase what you did. Everything is good. One detailed, remember each equation has only one equal symbol. I'm not saying you put more than one. I'm just refreshing your memory. Each equation has to be on one line, one row, and only one equal symbol. Yes, but you have to change this into negative, right? Because you have positive over negative. So you have to put the negative here. Because it was positive. Yeah. I use it myself all the time, as you know. Sure. We need more time? Okay, so here's what I would do. 12 minus 6x over x plus 2x minus 2 minus 3x over x plus 2 plus 3 minus 2x over 2 minus x equals 0. Now I will work on this, which is 2 minus x or negative x plus 2 or negative x minus 2. I will rewrite 12 minus 6x over x plus 2, x minus 2 minus 3x over x plus 2. And now I can skip one step after doing these 6 problems already. Positive over negative, it's negative 3 minus 2x over x minus 2 equals 0. I will state 2 restrictions. Yes. The least common denominator x plus 2x minus 2. And now adjustments. Jackie, if you need to get up and walk, please, okay? I don't need to suffer sitting for so long. Okay, then x minus 2, and then x plus 2. Is that clear? I have x plus 2, it needs x minus 2. I have x minus 2, it needs x plus 2. Are we okay? Yes? The top is fine, first one. This one is fine, negative 3x times x. Negative 3x times negative 2. But here I have to be careful because there are two binomials. 3 times x with minus in front. 3 times 2 with minus in front. Negative times negative becomes positive 2x times x. And positive 4x. Is this clear? Is it? So now I combine like terms. Of course, these two will give us negative x squared. These two will go away, nice. These two will give us a positive x, nice. And then I have 12 minus 6, which is 6. So everything is accounted for. I'm checking again. Everything, yes, everything is accounted for. Did we get this? Yes? Okay, so now cross multiply. So from here I have negative x squared plus x plus 6 equals 0. Of course it's quadratic. I refuse to work with a negative leading coefficient. So then we have x squared minus x minus 6. So then x minus 3 and x plus 2. Two options, 3 or negative 2. Not so fast. So x equals 3 is the only solution. Do we agree? Okay. Now I would like to look at these problems. Solve the equations for the indicator variable or letter. Here, I'm okay if you don't state restrictions. But stating restrictions for one variable, it's very important and useful to remember that these functions, later on we'll discuss about, not in this course though, about rational functions, what happens when they're undefined. Okay? So that is very important. So now let's not choose D just yet. So let's choose among these two and then we'll do D. Among these three and then we do D. Nothing new here, pretty much. We've done this before. So, okay, let's start with B. So we have A equals 1/2 H. In parentheses, A plus B. And they're asking us to solve for A. There are no news pretty much here. We've done this, as I said before. Okay. Well, this is the area of a trapezoid. It comes from geometry. So we're asked to solve for A. What will you do first?
Divide by 1/2 each.
True. You can do it in 2 steps. I would like to multiply first by 2 and get 2A equals H. A plus B, and perfectly, and you can do it in 1 step, divide both sides by H. Excellent. So then we have 2A over H equals A plus B. We are still solving for A. What will be the final step? That's it. So A equals negative B plus 2A over H. So I mentioned we've seen this before. The one we haven't seen before is this, because we did not know anything about rational expressions. Now we do. So all the other three, okay, let's work on this. A equals, any questions? P plus P R T. They're asking us to solve for P. Remember, there are many keywords in math, but 2 major ones are factor simplify that I hope you would remember from this course. So we're asked to solve for P. Okay, what should I do? Remember the two key words. Which one is applicable here? If I subtract p, I will not be able to solve. I cannot factor out p, indeed. I start with two terms. I have to have two terms in parentheses. Which terms? And I don't want to forget, I'm offering help sessions or review sessions every Saturday, starting from 12 to 2 in this room. Not next Saturday because the building is locked down. So 1 plus RT. So now I have to solve for P, final step. Divide both sides by. That's it. Okay, and one more and then we look at D. E equals I, R, H. We are solving for H. What does H equal to? E over IR. That's it. And now let's work on the last one. 1 over R equals 1 over A plus 1 over B. And we're asked to solve for A. I am not changing the rules on you, but this is a different situation. When we worked on something like this, we had X all over the place. I had here, here, and here. I moved everything to one side and set it equal to 0 to change it into a proportion eventually. Well, in this case, the variable is only here. If I move everything to one side, it will get more complicated. Will I solve? Yeah. But in this case, what I really want is to move 1 over b, find the least common denominator on the left-hand side, and leave 1 over a alone. What will be the least common denominator on the left? Of course, R and B have nothing in common. It has to be the product of the two. RB. And now what does each top need? B and R. So it's B minus R. Now, there is a minor trick here. Here's a trick. Is 1/2 the same thing with 2/4? Yeah, I can cross multiply. 4, 4, right? Or is this true? Now, if I flip both, I eliminate a step, and it's still correct. So that's what I'm going to do. But I have to do it at the same time on both sides. So then A equals RB over B minus R. So A over B equals C over D is the same with B over A equals D over C. Do you have to do this? No. You can cross multiply. But you have one more step. You have A times B minus R equals RB. And you'll get the same thing. You're going to divide both sides by B minus R. So A equals RB over B minus R. Same thing. But it's a good trick to remember. You can do that in a proportion, but only proportion. This is the last item from this chapter. This looks like very difficult. It's not. So allow me to decompose it for you so we can learn. These are called complex rational expressions. Why? Because they have operations with fractions in the numerator and operations with fractions in the denominator. And you cannot flip anything before you get one fraction at the top and one fraction at the denominator. So they require some work. I'm going to start with b. So 1 plus 3 over x minus 18 over x squared. Everything over 21 over x squared minus 4 over x minus 1. And then we'll choose the next one for you. There is nothing you can do here. You cannot flip. You cannot do anything but this. And you'll tell me what is my hint? What does my hint tell you to do? Yes. Simplify the top to one fraction. Then simplify the bottom to one fraction. And then just divide them. So initially, when you look at this, you say, I don't even know where to start. True. But if you just look at the numerator and say, oh, I have 3 rational expressions to add and subtract. I know how to do that. Then you look at the bottom and say, oh, well, I have 3 rational expressions to add and subtract. I know how to do that. So what would be the least common denominator in the numerator? And don't even look at the denominator just yet. That's it. This is 1 over 1, of course. And adjustments are needed for the first one. That's it. For the middle one. For the last one. Excellent. So then what do we have in the numerator of the numerator of the fraction found in the numerator? So nothing new. All we had to do is just add or subtract 3 rational expressions. I'll do the same thing for the denominator. What will be the LCD in the denominator now? All different factors, and they have to be at the highest power. Highest power present, not adding powers. Highest power present is 2. Adjustments now. For the first one, that's it. For the second one, that's it. And for the last one, that's it. So what are we going to get in the numerator of the fraction found in the denominator? Of course, the only restriction I can write now is just x not equal 0 because that's what I have in 2 denominators. Then, how do I divide 2 fractions? We know that. We review that. I keep the fraction from the top, and I would like to factor it. How do I factor the top? Over x squared times x squared over. And we'll talk about it in a minute. How do I factor, if it's factorable, the top of x squared plus 3x minus 18? X plus 6 and x. Very good. Okay, now when I flip the denominator, I see that I have a problem here. So I have to factor out -1 and rewrite the denominator. Because the leading coefficient is -1. So I have -x squared minus 4x plus 21. So I have to factor out -1. So what is left in parentheses? X squared.
Plus 4x.
Very good. Minus 21. Very good. Let's check. -x squared, -4x, positive 21. Perfect. Now, something can go away already. What is that something that I'm looking at? Of course. 1 and 1. So now the top is x plus 6 times x minus 3. There is a minus in the denominator, but I can also factor. How will I factor x squared plus 4x minus 21? Now I have to add 2 more restrictions. I did not have these as a denominator. I only had x equals 0, not equal 0, x not equal, because I am getting ready to simplify. And I have to state the restrictions before I simplify. So x not equal
7.
and 3. And now obviously I can further simplify. The negative sign goes in front. And then I have x plus 6 over x plus 7, assuming all these restrictions are fulfilled. Any questions? These are called complex. Not difficult, but complex. A lot of work, in other words. Okay, let's do one more and stop because I know you're tired. I know we have to add another 15 minutes. We'll do that on Tuesday. Please come on Saturday if you can, and if you have questions, and if you want, of course. If you don't have other obligations. Let's work on this. On Tuesday, I would like not to start chapter 12, but review everything one more time with problems from the book, the entire chapter 7. And we do not meet next Thursday. We need more time? Can anyone give us the denominator for the top? Yes, but we don't multiply it. So please keep it in the factor form. But it's correct. It's not a mistake, but we keep it in a factor form because maybe eventually we will simplify. Who knows? So we want everything in factor form. Adjustments for the tops. And it's also easier to see what the adjustments are because if I multiply, I may get confused. So this is, and this is good. So then 4x plus 9x plus 3. What about the LCD of the denominator? Good. So the same thing, 3x plus 1 and x. So can anyone give us the top of the bottom, the denominator, and the denominator? Very good, excellent. Of course, I have to write that x is not 0 and x is not negative 1/3. I copy the numerator as 13x plus 3 over x times 3x plus 1 times x times 3x plus 1 over 16x plus 6. Do we agree? Do we agree with this step? Is this okay? I have to add one more restriction from here. Negative 6 over 16. So x cannot be negative 6 over 16 or 3 over 8. Simplify by 2. So x cannot equal negative 3 over 8. And now I can simplify. What can I simplify? The whole thing. And the simplified form is 13x plus 3. You could factor out the 2 in the denominator and write x plus 3. There is nothing else.